Hi, in the second video, we are discussing morphological operations. Hi, in this video, I am going to explain how to do opening and closing. Opening and closing are morphological operations in digital image processing. For example, there is a question, apply opening and closing on the image sample A using the structuring element B. Okay, here an image sample A is given here and the structuring element is also given here. Okay, first of all, we are doing opening. Then how to do opening? For opening, we will first do erosion operation, then followed by the dilation operation. In case of a closing, we will first do the dilation operation and then the erosion operation. Okay, we can see how to do opening operation. In case of an opening operation, we will take the first row of the input matrix A. Then we will align the structuring element. Here the structuring element is 1 1 1. Here we will arrange or align the structuring element with the first element of the origin of the structuring element is aligned with the first element of the first row. Okay, before going to do some change of the pixel value, we will see the convolution approach of erosion operation. We want to know, or we know how the erosion operation changes the pixel value. That is the convolution approach. In the convolution approach, if the pixel value is 1, and then we will check the neighbor's value. If the pixel value is 1, then we will check its neighbor's value. Then all neighbors have a value 1, then the output value will be 1. This is a hit approach. If the input pixel value is 1 and some neighbors are 1 and some neighbors are 0, then the output value will be changed to 0. All our case, the output value will be 0. See, only one case, the input pixel value is 1 and all neighbors having value 1, then we will then the output will be 1. Okay. In case of a dilation operation, the input pixel value is 1 and all neighbors having value 1, that is a hit approach, then output will be 1. Then second case, the input pixel value is 1 and some neighbors are 1 and some neighbors are 0, then the output also 1, then the output value will be 1. Then see, if the input pixel value is 0, then we will check the neighbors. Some neighbors are 1 and some neighbors are 0, then the output will be 1. That means the input pixel value 0 is changed to 1. Then if the input pixel value is 0 and all neighbors having value 0, then the output will be 0. Only in this case the output will be 0. Okay, first of all, we are doing erosion operation. In erosion operation, only all neighbors having value 1, then the output value will be 1. In the erosion operation, all the neighbors having value 1, then the output value will be 1. See, here we are arranging or the origin of the structuring element with the first element of the first row. This is the first element of the first row. Then we will align the origin of the structuring element with this first element. Then now the input pixel value is 1. Here the input pixel value is 1. Then we will check the neighbors. Here there is only one neighbor. Then one neighbor having value 0. Then we will change the output pixel value to 0. Output pixel value to 0. Then we will shift the neighbors to the right side. Now the origin is aligned with the second element of the first row. Now this input pixel having value 0 and having two neighbors but one of the neighbor having value 1 and matching, but one of the neighbor value is 0, then we will the output pixel value will be 0. The output pixel value will be 0. All our case, if you then we will shift the structuring element to the right side. Then we will do the convolution operation or convolution approach. Then Euler case, the output will be 0. Then the final output is 0, 0, 0, 0, because Euler element having input pixel value 0 and neighbors also having value 0. Then we will take the second row. We will take the second row. We will take the second row. See the second row. Then we will align the first element of the second row with the origin of the structuring element, or the origin of the structuring element is aligned with the first element of the second row. Now the input pixel value is 0. Then we will check the neighbors. Here there is only one neighbor, but that neighbor having value 1, that is a hit approach. Therefore we will change the input pixel value to 1. We will change the input pixel value. Previously initially the input pixel value is 0. Now this 0 is changed to 1 here. Okay. Then we will shift the structuring element to the right side. Now the structuring element is aligned with the second element of the second row. Now this element having two neighbors, but the two neighbors having 0 value. Therefore the input pixel value is changed to 0 here. The input pixel value is changed to 0. Now the output will be 1, 0. Okay. Now this convolution operation, convolution operation is do for all the elements in this row, and finally the output will be 1, 0, 0, 0, 0. Then we will go to the third row. Same operation is doing here, and the output will be 0. Okay. Then we can see what happened in the fourth row. What happened in the fourth row? Then we will first align the input pixel. We will align the origin of the structuring element with the first element of the fourth row. The input pixel value is 0, neighbors having 0, the output will be 0. Then we will shift the structuring element to the right side here. Then again the output will be 0. Then again shifted to right side, the output will be 0. Then again shifted to right side, output will be 0. Then again shifted. Now the last element, the origin of the structuring element is aligned with the last element of the fourth row. The input pixel value is 0. It having only one neighbor, that neighbors having value 1. Therefore this is the hit approach. That means the value of the input pixel is changed to 1. Here in this case the value of the input pixel is changed to 1, because this input pixel having only one neighbor, and the value of one neighbor is value of the neighboring pixel is 1. Therefore it is a hit approach. Therefore the input pixel is changed to 1. Now the output will be 0, 0, 0, 0, 1. Okay. Now this same operation is doing for fifth row. Okay. And the final result will be 0, 0, 0, 0, 0. Now the final result. This is the final result after the erosion operation. That is, this is the input matrix A. That is the input matrix A, and we are doing erosion operation using this structuring element. Now the final result is 0, 0, 0, 0, 1, 0, 0, 0, 0, and all elements are 0. Now 0, 0, 0, 0, 1, all elements are 0. This is the output matrix after the erosion operation. Now we are going to do dilation. This is the input matrix. This is the input matrix, and we will do dilation operation on this input matrix. Now we will take the same thing. We will take the first row, align with this structuring element, and after the dilation, this is the result. After the dilation, then I will teach how to do dilation in the next step. Here, that after doing the dilation, here is the result. Now the second row having the increased size of the one is increased, and in case of the fourth row also the size of the one is increased here. Now this is the final result after the opening operation, after the opening operation. Okay, that is A opening B is equal to A erosion B, then dilation B. Okay, this is the final result. Okay, now we are discussing how to do closing operation. Here A is the input matrix and B is the structuring element. We are doing closing. For closing, we will first do dilation and then erosion. Then now we are discussing how to do dilation operation. Previously we are discussing discussed detail with how to do erosion operation. Here now we are discussing how to do dilation operation. Okay, dilation of A and B. This is a symbolic representation of dilation A, dilation B. Okay, similar case, we will take the first row, then we will align the or arrange the structuring element of the first element of the first row. Okay, here one input pixel value is 1 and some neighbors having 0. Okay, input pixel value is 0, so the output remains 0. Output remains 1. Input pixel value is 1, so the output pixel is 1 here. Okay, now we will shift the structuring element to the right side. Okay, now the origin of the structuring element is aligned with the second element of the first row. Now the input pixel value is 0. It's having two neighbors. One of the neighbor having value 0 and one of the neighbor having value 1. Then we will change the value of the input pixel to 1. Okay, how? We will, in the first case, we will align with the first element. In the second case, we will shift the structuring element to the right side. Now the origin of the structuring element is aligned with the second element of the first row. The input pixel value is 0. Then we will go to the neighbors. It having two neighbors. One of the neighbor having value 0 and one of the neighbor having value 1. Though some are 1 and some are 0. That is a hit approach. Therefore, the input pixel value is changed to 1. Okay. Then we will shift the structuring element to the right side. Having an input pixel value 0 and all neighbors having value 0. Therefore, output will be 0. Then again shift to the right side. Input pixel value 0. All neighbors having value 0. Then the output will be 0. Finally, the origin is aligned to the last element. Now they having only one neighbor. Having the value of neighbor is 0. Therefore, output will be 0. Then we will go to the second row. Okay, now second row is 0 1 0 0 0. 0 1 0 0 0. Then we will align the origin with the first element. Now the input pixel value is 0, having neighbors having only one neighbor. Its value is 1. Therefore, the input pixel is changed to 1 here. Okay, now the structuring element is shifted to right. Now the structuring element is aligned with the second element of the second row. Having two neighbors. Some here the input pixel value is 1. Even though the neighbors having value 0, but the input pixel is 1. Therefore, the output remains 1. Okay, input pixel is 1, so the output remains 1. Now the structuring element is shifted to right side. Okay, the origin is aligned with the third element. Now the third element having two neighbors. One neighbor is 0 and one neighbor is 1. So therefore, obviously, the value of the input pixel is changed to 1 here. Okay, the same thing should repeated for all the elements in the second row. Then final result is like this: 1 1 1 0 0 0. Okay, this is the output of the second row. Now we are going to the third row. We are going to the third row. Dilation operation is doing for third row. Here, how to do dilation operation in third row? We will first align with the first element. First element is 0, having only neighbors 0, the output remains 0. Then we will shift the structuring element to the right side. Now the align with the second element. second element having two neighbors, but one of the neighbor having value 1, therefore the input pixel value 0 is changed to 1 here. Okay, now the structuring element is shifted to right. Now it is aligned with the third element having two neighbors, all neighbors having value 1, but the input pixel value is 1, therefore the output remains 1. Now the structuring element is shifted to right. Now it is aligned with this pixel, the input pixel value is 0, but having one of the neighbor having value 1, therefore the output is changed to 1. The input pixel value is 0, but one of the neighbor having value 1, therefore the output value of the pixel is changed to 1. Okay, now we are shifted to right side. Now align with the final element, output value, input pixel value is 0, having neighbor value 0, therefore the output is 0. Now this same operation is doing. Now we will take the fourth row, the same dilation operation is doing here, and finally we will get the result like this 0 0 1 1 1, and then we will go to the fifth row. The output is like this 0 0 0 1 1 0 0 1 1. Okay, now the final result, A dilation B is equal to 1 1 0 0 0 1 1 1 0 0 0, and like this. Okay, after the dilation operation, we will go to the erosion operation. Okay, in case of a closing, we will first do dilation operation and then we will do the erosion operation. Okay, now this is the input of this is the output of the dilation operation. Then we will do the erosion operation using the same structuring element. Okay, then we will take the first row. Doing erosion operation. The result will be like this. Okay, then we will take the second row. Of this matrix. Now we do the erosion operation. Now the result of the erosion operation is like this, and we will repeat this erosion for all the rows. Then the final result is 1 0 0 0 0 1 1 0 0 0 1 0 1 0 1 0 0 0 1 1 0 0 0 0 1. This is the final result of closing operation. Okay, final result of the closing operation. Thank you.